Oh boy. Okay, we're back at it. Little different setup. This is the breadboard that I put together with the controller, digital reverse, and sound amplifier, and the circuitry and everything required to make that work. And it's getting its power from this Triplett PS305, which is a 30 volt, 5 amp capacity bench power supply. But I've got it turned down. I'm only sending 5 volts, 5.2, to the WeMOS. This sends out DC, so it's DC. And I've allowed it to go up to 1 amp, but as you can see, it's only pulling 0.2, 0.28, something like that. So sounds only are, and the motor, and the little fan motor voltage, which is about 1.5 to 2 volts, is coming out of the WeMOS. This is the name of the chip. Then, separately, and from track power up here, here's track power coming in from the transformer. That's going through this power distribution to this motor controller, to this DC motor, my DC motor, and that's also driving this trigger, right? So the motor is being driven by the transformer, and the sounds are being driven by this processor, and the smoke has been isolated, separate, and it's being run by a separate power. Whoa, he's a hot one. A separate power distribution board to a buck boost board right here. Okay, now, all right, so we're setting at 20 miles an hour. Slow it down a little more so you can see the chuffing, puffing. So that's 2 chuffs per cycle, and you could see if we had 4, you would just be obliterated because you cannot go much slower, really. Okay? Yeah, all right, there you go. You can go slower, but not much. So that's pretty decent. I like that. And that's on about 3.5 volts. Yeah, 3.5 volts. 3.5 volts to the homemade eye-wound smoke heater. And then you start cranking it up, and there's nobody going to complain about that. I mean, that's outstanding smoke. And you're up to 4.5 volts. I mean, I was getting 9 and 12 volts before, so I know this is going to be a very healthy smoker, and it's going to last a long time. That's the same nichrome wire. It's just a lot shorter, and it is wrapped around angel hair inside the heater box. I made it myself, okay? And now you got the DC motor. It's pulling, well, I don't have amp. Yeah, no, that's that. The board, the soundboard is only pulling 1.8, but you can't really hear anything because it's going too fast. There's the chuff comes back. But and I don't have a voltmeter on this thing, but you can see it's doing quite well. It's running quite well, quite strong. Then you're coming into the shop, pulling the load, smoking, sounds, everything's hunky-dunky. So in theory, in real life, with this setup, this Andy's design and what we've been putting together here with all the different components is working as designed. Okay? Chuff and puff, sounds, and digital motor and control and all that good stuff. Now, the challenge is I'm running the soundboard off of this desktop power supply, which is the size of a box of shoes. Okay, well, that's not going to fit in here. So what I now need to do is shrink that power supply down. What can I use to get a clean 5 volts? And if I'm only using 0.2, I mean, that's like a nothing, okay? So I should be able to come up with something for that does not pick up noise from anybody else. That's the challenge. We had that noise before. So now the noise is gone. I've separated everybody out. All right, who's the noisy one? Well, right now, nobody. So when I start integrating this system to package it in there, the noise may come back, and then that becomes the exercise. Why is the noise back? Who's making it? What can we do about it? But I wanted to prove to myself and also to you guys that the system does work, and it was working, and it will work. we got to iron out this power supply thing. And all this wire is just a mess. Don't worry about it. I'm just jumping and doing things here to make this work. But that's the brains of the outfit. This is a processor. It's a computer with memory. And then this is a amplifier. It takes analog sound and amplifies it and sends it out. Okay? And then there's some other circuitry for switching and whatnot. And this is the trigger for the puff and chuff. When you see the puff or you hear the chuff, that's because he's working. Okay, he's doing his job. Pretty cool. We isolated the heater, and now we're going to see if we can't bring the processor back to through some version of track power. Okay, that's it. That's where we are. Wanted to update you, let you know it's not messed up or a big problem. It's just a matter of figuring out the noise issue. All right, break's over. Lunch is almost ready. I'm going up. Later, gang. Hasta mañana. 502. That's like a big black Chevy. Remember that? 502, 502. Oh, what a beast. Okay, out of here.